Hello, I'm back. Um, okay, so there was quite a bit that we discussed on the last stream. Basically, to recap, we got into a point where the card deck in the game sort of became unmanageable, rather, for the primary or the most important kinds of things that you need to do in the game, which is build and place post holes, joists, and deck paneling. And what I showed you was what I think is a better design, or rather, kind of another very popular game that we can borrow from, which is Hades, which sort of faces a similar kind of design problem, itself being a roguelike deck builder and having that deck building concept, but not necessarily in the literal sense, in the sense in which um, a lot of card deck builder games are played, right? We're video games, so we get to do things that many other kinds of media can't do, right? So we can have deck building, but it doesn't have to be card deck building. So with that in mind, I did a few things. I started to do some designs. So I've got A Sprite open here. Um, what I thought was, what can we do that's kind of similar to Hades for these most essential things, right? So which I would consider the post holes, joists, and deck paneling to be the most essential. That's these three right here, right? Those are essential. Actually, I'll pull this over in case anyone's in the chat. These are essential, and so they need to be kind of separated into their own grouping, right? They don't quite work the same way as other things do. So what's a good way to do that? I came up with this sidebar concept. I had a few different iterations of ideas to go through because there's this concept of action points, right? So action points are a kind of currency. They're a sort of cost system that we're imposing in the design of this game. Certain things, if they don't require resources that you go out into the world, so in this case, the one resource that I have in the game right now is stone, right? So that's stone. If they don't require this other resource, because that basically, in order to kind of, we've got a bit of a like what I would call like a bootstrapping problem, right? So I'll run the game just to kind of illustrate that. You'll notice that I got rid of the cards. We have a bootstrapping problem, which is to say that um, I have the post holes and joists and panels, right? I I can place those, but I need to be able to place at least a few of them in order to get to my first resource. So the first things that I build can't require the resources that I am going to get to, right? They need to be basically free, or they need to cost some other thing that kind of self replenishes every turn. In this case, I just invented a thing, a resource, and I call it energy, right? And I'm not sure if I'll keep that or I may not keep it, but I'm just calling it energy. And you get 7 a turn. Again, I'm not sure if that's the right amount or if that's kind of what I wanna stick with, but I just kind of invented that. And so you start with 7 energy, and then the currency, the thing that it costs to build any kind of post holes or joists or deck paneling, it costs this energy currency, right? So I get to spend a certain amount of that per turn. And then some of that kind of replenishes every turn. And you can imagine that now that we've introduced energy to the game, um, it can sort of filter into a bunch of other things. So maybe there's a building that you build, right? And we just call that like a solar collection panel, right? And that thing collects a certain amount of energy per turn. Or maybe there's like another resource out there in the world where if you build something next to it, you collect energy, right? So maybe just the default amount of energy that you get per turn is not necessarily um, that's not necessarily going to stay, right? So there's going to be things that you can build or things that you can discover out there in the world that can increase that amount of energy. But I think it's a good starting place for a design. I think it's a good thing to say, okay, well, just to start out, just so you can get going in your deck building, we'll have this concept of energy. And then what I thought was, okay, well, let's design, let's just get this first iteration of this design going. So this is the same thing that I had on the cards, but now it's kind of like a side panel. It still has the name, it still has the icon. So I've kind of redesigned it here. And then it's got the energy cost right next to it. I picked this design because out of all of the other designs, so I tried some other designs. It's maybe a little bit of a good, I was just doing this morning actually. I sat here and thought, okay, well maybe it's like this. Maybe it's like a small card or something, or maybe it's like a little like button with a circle around it. So I liked this one because it was minimal and maybe I could just have a handful of them sort of in the bottom corner of the screen. But then I decided against that because, well, primarily it does not explain or does not have the cost on it. So the key thing here is that this costs something. And that's maybe the design difference between this game and like Hades. In Hades, there's only one of the, well, actually, most of the actions have no cost, right? Attack has no cost. Special has no cost. Cast does have a cost, but they're very clear about making that cost really visually apparent to the player. So I think in Hades what they do is they have the little diamonds, right? And so every time you cast something, when it hits, a little diamond pops out, and then you have your like amount of casts, and so it's very clear to you. I'm running out of casts whenever I do it. Not only do you have a little bar on the screen, but you also have, could it be a translucent post hole where you intend to build with the cost next to it? Yeah, that's a possibility too, is like putting the cost on the map itself, right? So this design has the cost right next to it on the menu item, but you're right that when the game draws all of those like transparent post holes on the map itself, you could also put the cost next to it there. I guess the reason I chose not to do that is I think mainly just visual clutter. Mainly that if I were to do that, I would have to put the cost next to every potential place where you could put a post hole. And then it's kind of like, do we really need to have the cost? Because if you put the cost there, you have to put it next to every single one of those. I feel like you can't just put it next to one and then not another, because then that's kind of confusing, right? Because then I'm like, well, why does this one cost, but then that one doesn't? So it's like you'd have to apply it consistently, and you'd have to say, okay, well, we're going to put the cost next to every translucent post hole. But then to me, as just looking at it visually, I think that might be like cluttered. It's kind of a lot of excess drawing for the same amount of information, versus this, where there's it's clear that there is a cost to it, right? It's like right next to it. And then as you play, you'll be able to see that your amount of those is going down. And then I think also once you've run out of energy and you have no more of an ability to place those down, at some point, you can also visually indicate right next to this. So when you're out of energy, maybe just like as a really quick thing you could do is you could gray those out, right? Or you could like have them be like half translucent, or you could put them in front of like a gray background and then like alpha blend or something like that, just to be like, hey, you can't use this right now, right? And then maybe what you can do is like you can put next to it like a little icon, like just saying that you have no energy. So you can make it really, really clear why you can't take the action, if that makes sense. So that's the thinking, and it'll definitely have to have that, right? You have to put in, I think even when you're prototyping, you have to put in a lot of these kind of, especially if you want it to be a playable prototype, you have to put in these kind of like user interface niceties, or like a lot of people call it user experience design. Kind of a fancy term, but like I just like to say like things that you put in the game to make it so that people aren't confused, right? If you can't do something, it needs to show people that you can't do something, right? So I got thinking a little bit also, because this is like thinking just a little bit in the future, because eventually what I want is for this to be expandable. So I want you to have multiple like slots in this essential slot. So I think I want you to have the ability to like, so like maybe there's something I can click here, right? Maybe there's like, so what the example I have here is just a, what if, I'm not saying the game will go in this direction, but maybe like a fully realized version of the game will. But maybe like there's water tiles out there, right? So I'm calling it Rogue Deck Builder. But maybe like once you get like right up to the water, then the game becomes Rogue Dock Builder, right? And so you have these like water post holes that you put into the ocean or something. Or maybe there's like, maybe this is like a calcium carbonate kind of special post hole that only goes in the water, or something like that. Or maybe it grows, right? Like maybe when you put it in the water, other post holes start to grow next to it, or something like that. You can imagine like something else that's special, that's not your basic type. And then what you could do is you could click here, and it would just swap over to that one, right? And then it would display the cost and everything, but like that could become your active one that you're using. And so this is almost another thing too, is like this can kind of keep expanding. So maybe you get like 3 slots like that of different things that you could put in that slot. And then you could just swap between them, kind of like picking colors in a palette. And then each of those will have a cost, and you'll be able to just put them down. But that's kind of the thinking, is this is like just enough space to show what the cost is to have an expansion slot. I'm not going to do the expansion slot right away. That's going to come later. But the basic idea is there are these 3 essential things that you need in the game. They all cost this currency of energy. And I'm going to draw them on the left side of the screen, right? And then I'm gonna make it so when you click on them, that's your active one. I'll probably do a few things to kind of make it apparent that it's your active one. So maybe what I'll do is when you click on it, this section gets moved out 1, right? So that's a possibility. I might do that. There's other ways, of course, to indicate that it's the selected one, but just it needs a little bit of something to indicate that. So that's kind of where I've gotten in terms of the actual design. This is just a first pass on it. There might be a better design later on. I'm not really sure, but this is kind of what I landed on. So I'm going to try it out, and I've already got. So this stream is going to be a little bit more of a programming stream, just because I actually, after my last stream, I was like going to start coding all this stuff, and then like I had a bit of a doggy emergency. He's fine, but that sort of took over the rest of my Friday. But I'm back at it. So my dog ate a toy that he should not have eaten. Okay, so I've got right here the sidebar that I'm just drawing, and a lot of times what I do is I just draw things tile by tile. So pretty much everything in the game that I draw comes down. It's represented in some place on this sprite sheet just as some kind of a tile, right? So a lot I use a lot of these 3x3s. So this is just I call it a 3x3, but all it is it's just a quick thing that I can use. And if I use one of these, I can kind of get the like a rounded edge of something, right? So in prototyping and doing just the artwork for things, I like to just quickly throw together a bunch of these 3x3 sort of. You can construct all kinds of things out of these 3x3s. You can make, I made the cards out of that, right? So these cards, basically just using the 3x3s as tiles. This end turn thing, that's just using the 3x3. Actually, the top, the game has. So this thing, like right in the top corner here, that's just using that 3x3 to kind of draw an area. So it's actually those 3x3s when you're just prototyping are actually really good for just any kind of UI that you might need. But you can use them for a bunch of other stuff too. So here's another example of a 3x3. Actually, the top of the deck is just this 3x3, right? So depending on which part of the deck is covered, I use that 3x3. When the deck is under attack, I use this 3x3. And then I use this one for like the not yet completed sections. So this looks a little bit like scaffolding, or like a kind of like a joisted area when it's not complete. So I use this one. But yeah, these things the 3x3s are super useful. You can actually construct a great deal of user interface out of that, basically for prototyping. But I think even on like a lot of like professional games, professional, whatever, like say a game like Factorio, a lot of the user interface is basically just, slightly more sophisticated versions of these 3x3s, right? So you could animate them, or you could have much better effects, higher resolution artwork, all that stuff, just using these 3x3s. So that's what I'm using to do this. So I'm basically just using this same tile 3 times, right? And then I'm going to do this tile 3 times, and then I'm going to do this tile 3 times. And so what I could do is something like this. So this is just the column, but so this is doing the top part of it. Then what I can do is I just nest that inside of another for loop to do the rows. And then at the top of it, it's funny because I feel like I do a lot of these on the stream, but I guess it's just that I end up, that's kind of where I end up by the time I start the stream, is like I need to do this part of the job. So all this does is it just sets the, because every time you move forward in the columns, then the X moves forward by 1 tile. So all I'm doing is I'm just like resetting that. And then I need to increase the Y. And now if I were, so at the end of every row, then we're just going to increase the Y. And I'm calling my own, basically where I'm at right now in terms of my game development is I've built enough of my game engine, or like I have enough leftover code from previous projects that I have this push textured rectangle function, right? And so that push textured rectangle function, if I go into like my rendering library, this thing right here, right? There's a lot to explain. I think I actually on the other stream, which I didn't record, I explained all, or at least a good portion of what goes into this. But basically I pass it these variables, right? Like this very top level structure, and then I tell it what kind of texture atlas, like the size of it, or like sprite sheet I want to use. And then I'm using vector2 for the, this is basically a rectangle. This could also be a rectangle, minimum and maximum. It's very similar to what Casey Muratori does in his stream. But I'm basically passing this thing a rectangle that says this is like a textured quad that I want you to fill in with the texture. And then alpha blending, right? And then like what layer it's sitting on in terms of Z. So all of these get sorted from back to front. And then rotation. So this thing actually uses a little bit of matrix math in 2 dimensions. Well, no, technically 3 dimensions in order to do 2 dimensions. But it does a little bit of matrix math in order to get, apply some of these effects like rotation to pixel art. So I can also pass this thing a rotation in radians, and then it will just rotate my sprite if I want it to do that. Most of the time I don't actually want sprite rotation, so I usually pass 0 to that. But yeah, it's all to say that I've gotten to a point where I have a handy abstraction that I can use to just draw rectangles that are filled in with this texture type. So some of you, you might be starting out with like, I know there's like Odin plus Raylib. Raylib would do a lot, like Raylib would provide that abstraction for you, right? It would provide that, I want to draw a rectangle. I'm crazy enough to have done my own in C++, but there are other kinds of ways that you could achieve a similar thing while making games, right? So anyway, so we just have to kind of assume that this abstraction works, right? Because I made it and I know it and it works. So if I tell it to do it, it's going to do it. Now the texture ID that I pass in here is that's going to have to change, and I'll show you why actually. So I'll just compile this right now. Right, so what's that doing? It's kind of starting to draw my sidebar thing, but it's actually drawing like just the top part of it, right? So I need to swap that out. And actually, I'll show you that too. So this is just a big high-level structure that I use to basically every single unsigned 32-bit integer in this structure represents a unique identifier for a texture or a tile that's in this sprite sheet. So every single one of those is some tile that's in this sprite sheet. So like the top corner of this has its own texture ID. This version of this guy facing this way has its own texture ID. The gun has its own texture ID. All of those have their own texture identifier. And so when I do these 3x3s, in order to do the user interface, like I was just showing you, I just have an array of 9 of them, right? And so it's basically a two-dimensional array. So I think I use the card backing 3x3 here. And so it's just an array with 9 indices in it. And then you can imagine that so 0, 1, 2, right? So 0 is going to be, so 0 is this one, and then 1, 2, 3, 4, 5, 6, 7, 8. So if I'm going to be drawing just, in order to draw like this thing here, right? I want this tile 3 times, and then I want this center tile 3 times, and then I want the bottom tile 3 times, right? So what would I do? Well, on the first iteration, I would use 1, right? On the first row, I would use 1. And then on the second row, I would use 3, right? Oh, no, wait, not 3, sorry. 1, 2, 3, 4, 4. So 1 plus 3. And then 5, 6, 7. And then 4 plus 3. So I'm basically adding 3 to that base index every time I am iterating, every time I'm drawing one of these things, right? So let's, all I'm gonna do is take this thing here, this index 1, and I'm just gonna make it just a slight bit more abstract, right? So how would we do that? Well, first thing I would just declare outside of this scope, base texture index. Actually, we don't even need to do that. So this is going to be like 1 plus 1 plus row times 3, right? So why does that work? Hang on a second. That works because, so I imagine on the first time that I'm iterating through this, right? Row is 0, so it's just going to be 1, which is correct for the top row. On the next iteration of row is going to be 1, so it's going to be 1 plus 3, which is 4, that's correct. And then on the third iteration, it's going to be 1 plus 2 times 3, so it's going to be 7, right? 1 plus 6. And so that simple thing should get us there, right? So you can actually use a lot of these kind of convenient, they're very convenient. I'm trying to think if there's, another thing that I might do is have another, then I can get the whole thing. So I'm actually going to just do one more of these, but here's the difference. I'm going to draw another one at the very end of this for loop, because this column loop, right, it's the same tile. So that's the reason I can use this like inter-nested for loop. But if I just do this same thing, right, but then instead I go 2 plus row times 3, then what that'll do is for each of these, on the first iteration, it's going to give me this. Then on the second iteration, it's going to give me this. On the second row, it's going to give me this. Are you getting the 9 of them? I'm not sure I understand what you mean by that. So here I would need to do 9 of these, right? 9 tiles in the array. Where am I getting them? Or like, how am I getting them? How am I loading the artwork? Is that the question? I guess I'm not really sure what the question means. Can you be more specific about that? So I guess like one way of interpreting your question would be, how is the game loading all of this artwork? Is that the question? Like, it would need to load each tile, each of these tiles, right? In order to, well, they need to be in memory somewhere, right? So, presumably somewhere on the GPU, they've got to be like in VRAM or something, right? I actually don't know all the specifics of how all this works. I'm not that technical, but essentially, like they would need to be in VRAM. The texture's got to be somewhere, right? So I got to load somewhere in my game engine. I've got to like load this sprite sheet, right? I've got to load the file, and then I've got to go in and I've got to like sample each of these tiles, right? And I've got to put them in memory somewhere, right? And then when I put them in memory, I have to associate them with a unique identifier, right? And then I need some way of mapping that unique identifier to the texture itself in terms of my graphics programming language that I'm using on this platform, which in this case, because it's Windows and it's my Windows platform layer, I'm actually using DirectX 3D 11. However, since this is cross-platform, I use a different rendering language on Mac OS. So on Mac OS, I use Metal. But they both do similar things. So somewhere in my code, I do in fact have there actually is a place where these are loaded into memory, and then they're sent over into I think in DirectX 3D 11, it's set up as an array texture, and also in Metal, it's set up as an array texture. And then I'm populating that array texture with what I've loaded into memory from all of these. And so is that the question? Like, where do we actually get the graphics? Or did you have a different question? Okay, cool. I mean, if you want, I can show you like a little bit more about where where specifically this is, like what exactly it's doing. So just to, I'll kind of go through like at the high level, and then I'll try and get to as much as I can. So okay, so win main is the main function. This is like the main entry point of basically any kind of program on Windows. I think not all of them are this way, but a lot of Windows programs have that. Oh, I don't need the sudo anymore. I did figure that out. So, obviously this is where like all the boilerplate setup is going to be for any kind of game that you do, or any kind of like game engine, or really anything you're going to be doing. So mine, I am starting by allocating memory, right? So if I'm going to load graphics onto my system, I need to allocate some memory for the graphics to go into, right? And the way that I do that is I just allocate a big chunk of memory up front, and the graphics they're going to go in some partition of that chunk of memory, some subsection I'm going to be loading bitmaps into, okay? And so I'm doing all the memory loading, setting up memory partitions. First thing I do is I load all the game sounds. Because this is a really early prototype, there are no sounds. Next thing I do is I load artwork. So I have this function called load pixel art textures that I call from this Windows main entry point. And notice that I'm passing in a pointer to my game's memory that I've allocated, to this big structure that represents all the memory. And so if we actually go into that function, so this is my big ass load pixel art textures function. It's like what, all of 500 lines. It just loads everything, right? So it loads everything that's in that one texture that I've got. So in this case, I have a cross-platform function that I created. It's called platform read PNG file, and then I pass it in, this PNG file that I've been using, this thing here. I pass it in a reference to it where it is in the file system, right? And then what it's going to do is it's going to give me basically a pointer to the start of where the actual graphics are in that file, right? So that's what this is. Now, how do I get that pointer? Actually, I use a library. So the library that I use is called STB. Should be in here somewhere. STB image, I think. I use maybe it's in core. Yeah, STB image. That's not mine. That's Sean Barrett's, and it's a great little like one header PNG loading thing. So I like to say that I do a lot of my stuff from scratch, but I don't do everything from scratch. Actually, like when it comes to things like dealing with certain file formats or whatever, sometimes there's just a really good solution that works, and so I use this. It'll load a PNG file for me, and then I get a pointer to the start of where the graphics are, and then that's what I do. and then once I have that, I've created a few other kinds of handy abstractions of my own that I found useful in the course of making games. One of those is a sprite sheet. And so a sprite sheet just says like, hey, where's the data? I need a pointer to it in memory. Where's the actual pixels, right? Then like how wide are the textures? How tall are they? How many textures are there in a row in this sprite sheet? How many textures are there in a column? And using that, I can then I can individually go through and I can say, hey, the gun is located at row 7, column 4. And when I load it, I want it to go into this, one slot on my texture map. From that comes the ID, right? Yeah, so the IDs the identifiers are basically generated after the textures are loaded, right? So it's gonna, and I think it's not even that they're generated, they start at 0 and then they count up. So you can imagine, right? Like, oh, I need unique identifiers. There's a lot of different ways you could do that, but for me, the simplest thing was, look, like we just start at 0 and we go up, and I always reserve the 0th one for missing asset. So the reason that I do that is just a lot of time I like to reserve 0 for a lot of different things, but I actually have like my own. I think on this I've got the X somewhere. Yeah, here it is. Here's missing asset, and so that's just like if somewhere in my code I happen to have there's some part of it where like I always assign things 0 to begin with. So 0 is initialization. That's kind of my philosophy. Not my philosophy, but I stole it. I think that's Casey's philosophy. So 0 is initialization. So I set it to 0, and then as I'm kind of going through, if it gets filled, then it'll be the right texture. So 0 is always missing asset, and then the identifiers count up as I load more and more textures, and then that identifier serves as an array lookup into the array texture in DirectX that I'm telling DirectX to draw on the GPU. So this stuff goes like this idea of the unique identifier for textures. It actually goes all the way into so if I look at my actual like shader, this is my pixel art shader. Seems like, yeah, it's as easy as I could think of it. I mean, I just kind of was like, here's a simple way to do, to do textures on this. And I was just like, well, what's going to be the least onerous? And so I have, this is like an instance, right? So I use a thing called instance rendering on DirectX, and you'll notice that one of the things that I have as my instance variables is this texture ID, and the texture ID then functions as a lookup into an array texture. So that I believe is used in the pixel shader. So that would be right. Where is it? Here. So this line here is the float vortex. So what I'm doing is I'm taking the one texture. So I only have one texture. So just to do these simple prototypes, because we're not doing the art, we're like really only focused on gameplay here. I have one texture. It's just one big ass sprite sheet. It's basically this thing, right? And that's what that's the thing that I'm loading. And then I'm just going to sample into that. This thing here is what we'll use my, this is where I pass the texture ID as the array lookup, as the array index lookup into this big array texture that I've allocated on Direct3D. And it's I actually do a similar thing. So if you're thinking about cross-platform, I'm not on a Mac right now, but I could show you that it's basically the same thing on Mac OS. So the pixel art, yeah, the fragment shader is essentially, yeah, this right here. And you'll see also that there's this texture identifier as well. So I'm doing exactly the same thing in Metal, but just in the Metal shading language instead of, Direct3D. So if you were on a Mac and if you were prototyping your game on a Mac, you could basically use the same setup to do it. So hopefully that kind of clears it up. But basically, I might even be able to find the place on Windows where I actually allocate that array texture. So it's going to load the pixel. Oh, okay. Well, this is saying that I initialize the memory after I've loaded the textures, which is kind of interesting. But I think what that does is it just like, it's more like a game state initialization. So it's not going to like wipe out all the textures that got loaded. So that just is worded more confusingly. This is stuff that I do for Steam, which I don't care about if I'm supporting Steam. But there, I wanted to get to okay, if there's sound, there's a bunch of places where I start to set up like all the rendering. There's vertex buffer. There's yeah, so this is also where I set up DirectX rendering. So this is actually where I set up the big texture atlas, right? So that's a function. Let's see if I have setup instance buffer. I think it's in a different file. Renderer setup. Yeah, here it is. Okay, so basically, well, maybe not. No, that's the instance buffer. That's not the actual graphics. Where do I set this up? Texture, pixel art. Okay, yeah. Here it is. Set up shader resource view. That must be in a different thing. Shader resource, that sounds right. So this is where I set up that texture that I was talking about. This is basically the big sprite sheet texture. And this is the DirectX version, the D3D11 version of doing it. Like I said, you know, on macOS, it's going to be the metal version of doing it. But yeah, I basically pass in, here's the number of textures that we loaded, and we're going to use like a texture array in order to do that, right? So I'm gonna set up a texture array on DirectX 11, and then it's gonna, you know, I fill in this description, right? So how many, you know, how big is the texture, how tall, how many, so in this case, because it's pixel art, I'm doing like 16 pixels by 16 pixels for the width and height of an individual sprite. And then the array size is just however many I loaded, right? So however many of these I intentionally loaded. So it's not going to load everything that's in this big file. It's not going to step through all of these. It's only going to step through the ones that I tell it to. So it steps through, I think I tell it to load like this. Basically, most of the stuff that's in this region here that's actually used in the game is what I tell it to load. And so then it'll load those. So it's going to load those. And then it's going to, then basically I'm just filling in this array texture. So now on the DirectX side, all of those textures are loaded and they're in the array indices where that map directly to the texture ID. So kind of end to end, that's actually what's going on here. Is I'm just saying like, you know, if I get index number 3, it's going to correspond to, or a texture ID number 3 is going to correspond to that. And all that this texture map thing that I have is it's just kind of a handy abstraction for me personally, right? So that I can have a way of saying, I want to get the textures that map to the back of the cards, right? I want this 3 by 3 here, right? Or I want to get the player, right? There's another one for the player here. So, and then that's in the order of like the directions that the player is facing, right? So the player is facing like this direction, this direction, this direction, this direction, right? So that's just, it's just a convenient kind of simple way of me, it's a way for me, because you know, you imagine like, you could also just load all the textures, right? And then just not ever keep track of where things are, or like try and like, you know, figure out the array offsets yourself. But why, you know, why not just like store a copy of it somewhere and then associate it with a variable so you can just pass it into some function. And so that's basically what I do. I have this like texture identifier abstraction for that purpose. So, wow, I can really like talk about anything at any level of depth. So essentially, again, you know, kind of going back How am I handling things in UI space versus world space? Oh, that's a great question. So in UI space, right, I have the advantage of just being able to say, this thing goes at, so when I'm drawing, you'll notice that when I'm drawing the this thing here, I can actually, this is like the left top of it, like the sidebar here, right? When I'm drawing that thing, I have the advantage of just being like, okay, you know, on the x coordinate, like so in absolute world space, zero in x. This is actually needs to be flipped around, but like hopefully you get the point. 0 in x is the far left side of the screen, and then like the furthest possible right on the screen is just going to be screen width, right? So I actually hang on to that variable. Wait a second, I don't want to do that. I'll show you. Render commands. So I hang on to viewport width and viewport height. And so viewport width is just something that there's basically when the game starts up, I use some Windows APIs to get the width of the screen and then the height of the screen, and then I store that. And so if I want to do like layout, a lot of layout is just basically, say I want to put something in the center, just give me like half of the width of the screen, right? And that's my X coordinate, or like give me half of the height of the screen, that's my Y coordinate. So in terms of like absolute screen coordinates, that's actually pretty, that's the easy case, right? Anything that you just want to put on the screen, absolutely, that's easy. Gets quite a bit harder when you're dealing with something like this game, where you imagine that the entire game world itself does not fit on the screen, right? So the game world itself actually is much further along the edges. Like let's say that it's 1,000 tiles, right, in the X direction and the Y direction, and each individual tile is going to be drawn on the screen as like 80 pixels, right? So 80 pixels across, 80 pixels tall, right? Well, essentially on any given frame of drawing the game world, you're not going to draw. So actually what I'll do is I'll just run it so you can see. I don't draw the whole world, right? So as I move around here, the whole world actually extends beyond this screen space, right? So if I tried to draw the whole world, first of all, that would be very slow and inefficient because I'm like forcing all this stuff into the render pipeline, but also wouldn't be much of a point in doing that because it wouldn't be able to fit on the screen. So what I do is I figure out basically a window of tiles around the player that I actually want to draw. And then you have to calculate, you have to do this kind of like transform from world space, right? Which is where these things exist. They all have a kind of an absolute world space. They're at some position on the tile map. Let's say the tile map is 1,000 tiles. Or I think in this case it's 100 tiles. So it's much smaller, but still it doesn't fit on the screen. I have to do this transform from the tile map position to an absolute screen position, right? So just to kind of give you a sense of where do I do that, right? I do that in a lot of different places. So actually I do that when drawing all the game's entities that are in the world. So where is that? Right here. This is the stats for the player. This is that. Oh yeah, so here's all the entities in the world. But I basically have a, if the thing that I'm going to draw, so this so basically what I do is as I'm going through all the entities that are in the game, I figure out where it is relative to the camera, right? So the camera has a position, right? And I'm going to only draw a certain amount of things that are in a box around the camera, right? So let's like maybe crack open this function right here just to when the player starts edging the coordinates that haven't been drawn, a chunk of the world is drawn. Um, I mean, it kind of, it's actually a little bit more sophisticated in the sense that it's always going to draw a section of the world around the player that is enough on every frame. And so you got to be thinking that this thing is updating itself 60 times a second. It's updating itself so fast. Like, right, like on a scale that is really not like most human beings kind of can't really think. you know, 16.6, milliseconds every time that passes, the game is both updating and rendering, right? So, and it's actually drawing in that 16 milliseconds an area that is it's slightly larger than the size of the screen. So you can imagine that there's maybe like a little like envelope around the screen, right, of stuff that it's drawing. I can even use like a thing. I like to use this tool called Render Doc that shows you all the stuff that it's drawing. So here's this. This will, if I run it, I can just get like a capture. So I'm just going to run it. Hit F12. Actually, I'll do full screen. Hit F12. All right, now close. So this tool can show you. It shows like a wireframe mesh actually. So here's that wireframe mesh of all. This is all the stuff that it's drawing, right? I wonder if I can even see outside of it. I don't think I can. I think actually there's some optimizations where if you give it coordinates that are not necessarily inside of it, it will still, oh, here's an example, right? But it gets cut off. So I am drawing this rock here, and there are vertices outside of here, but the vertices are actually not inside the screen, so it just gets cut off, right? So anything that's outside of this, it's basically doesn't get drawn. But I think the main reason that you don't want to generate all those extra draw commands. So maybe what I do is I tell it, I still send the commands for like a little like envelope slightly outside just to make sure that there's nothing that I miss, right? But on the GPU side, I think all of that just gets optimized out. So the only cost that you would incur is like a CPU cost in like putting those in getting those commands set up, basically. So you're setting up commands that you don't use, which is waste. But and you could get like really, like if you really wanted to, like maybe you could get really into the detail about that. But basically what I do is I just draw an envelope around the screen. And so if I like zoom really far out, then I'm not even telling it to draw anything that would be in this part of the world, right? Because it's so far from the camera that I just know it's not going to be fitting in the screen, so I don't draw it. That's basically the how I tell it to do it. So yeah, well, you're always seeing like a little window into the world, right? It's you don't need to there's no point in drawing the whole world, so you should really only be able to draw what could fit on the screen, and that's pretty much like any game that you play. There's a lot of different versions of how this is handled, but even in 3D games, they draw like a cone around the vision, right? So they only draw what comes out of what's far enough away that you can see it. It kind of fits into this cone. If you tell it to draw 3D models that are like way outside of that cone, it basically doesn't. What's the point of doing that? You're just wasting CPU cycles, right? And you're wasting resources on the GPU. And there's all kinds of other optimizations that are in play, like If you have a 3D model, like something that's right in front of you, it'll draw the front vertices, right? But it won't draw the back, right? Because that's waste. And so there's special ways of looking at the actual um, how the vertices are laid out, where you can tell if you're drawing something that's on the outside of the shape or on the inside or on the back, right? So all these like different ways of figuring that out, so that essentially the GPU only really draws like what's on the front side that you can see, and that's a huge optimization. That's how you can get really great looking 3D graphics at high speeds. So tons of optimizations that don't draw things you can't see. Yeah, yeah, exactly. Right. So yeah, that's a good point you're saying. Like it can get really tricky. Um, and that's up to you, the designer. Like what stuff do you want to, so like let's say that in my game, um, when I tell it to start a turn, right? It's like we're in like the deck defense phase, right? A bunch of zombies are gonna like, or zombies or neighbors, people, they're gonna like generate on the outside of the deck, and then they're gonna come after you. Well, those people, they're not in the space of the camera, right? You're not gonna see them, you know. You're gonna see, you're at least at first, right? So, but then eventually they will get onto the camera. So you need to you still need to update them, right? You still need to like update their physics, get them moving towards you until they get onto the camera. So yeah, there's going to be different things. Usually you want to update all the entities that need to be updated, um, but you don't necessarily draw them, right? So they're being updated, but they're not necessarily being rendered. You're really only rendering stuff that you can put on the screen. So, and that's not all games necessarily. A lot of the really older school games, they weren't able to do that kind of thing. They weren't able to like do the update on all the entities or all the stuff that's in the world because precious CPU cycles. So I don't know. I guess like a game that comes to mind is like Mega Man 3 for the original Nintendo, kind of a game I grew up on, where that game, if you just play it, like there's a few stages where a bunch of guys will like spawn into the room and it gets so freaking slow like once there's like three enemies on the screen. So that's just to show you like how much they had to conserve resources on the original Nintendo, right? It's like if three enemies is like too much, you know. But now like we have a lot more CPU power, so we can actually have games with larger amounts of entities that are further away in space, and we can update them and it's fine. But if your game isn't running fast, like that might be a reason, right? There might just be too much stuff that is updating that shouldn't be updated. So I hope I answered that question. I actually kind of want to get to like the camera, so I could show you like some of the camera stuff. Um, there is, let's see, get position in screen pixels. So I've sort of eventually kind of come up with some logic that can do this like relative. So this get position in screen pixels is a function that I came up with. That's actually based on some like what Casey Muratori shows in Handmade Hero. But basically what I do is I get a relative distance between an absolute position in the world and then the camera position. And then I use that relative distance. I say, I define, I say the camera is always going to be in the center of the screen, right? That's just where I've said the camera is. Camera is always the center of the screen. And then if you have that constraint, then you can get the relative distance of any entity from the camera, and then you can use that to figure out the absolute position of that entity on the screen in screen coordinates, right? So then it's just basically some distance from the center of the screen. So I can use that to figure out the position in screen pixels. So I say, because I've said that the camera is the center of the screen, right? I can then say okay, well, anything else is positioned in screen pixels. On the x coordinate, it's just going to be the center of the screen plus any distance or any difference between that position and the camera, right? And then similarly for the y position. So that's how I can get back to, I can convert between those two coordinate systems. I can convert from world space coordinates to screen space coordinates. And again, not everything is going to have a screen position, right? There are things where if you calculate that difference between the camera position and its world position, that difference is so far, like maybe the x coordinate is like negative 1,000, right? Or like the y coordinate is like, you know, 2,000. So it's like clearly off the screen. So another thing you could do is you could calculate that position, and then if that position doesn't fit inside of the area of the screen, like the viewport, like 0 to viewport width, and then zero to viewport height, then it's clearly not on the screen, right? So therefore, don't draw it. So that's something you could do as well. Just like that might not necessarily be the most efficient way of getting at that, but it's just to say that, hey, there's a way of figuring out if you should draw it, right? Because one thing I could think that you might want to do, instead of actually doing that actual like coordinate transform, you might just want to do some really quick sanity checking. Like, what's like, how many tiles away is this thing from the camera? Anything that's like, 500 tiles away from the camera is definitely not on the screen. So like, don't even bother doing the other calculations. That's something you could do. So I hope that answers that question. That's how I do it. Top of the hour. I'm actually just gonna try and run this and see what happens because I think this should work. Okay. And sure enough, we've got like at least the back base of this. And again, I can pull that up into a function, and then I can use that same, I can use the same logic here. Wait, where was I? Not here. Yeah, I can use this same logic. I can just pull this into a function, and then I can just pass in a different starting position for it. So imagine instead what I do is, and then I can like use that to draw like the 3 different ones, right? So basically, once I've figured out how to draw like one of these, then it's very easy to be able to draw like multiple of them on the screen. And then you can easily go from that to what happens when I hover over it and select it. So I imagine by tomorrow, I'll probably have all of that stuff actually in the game because I am actually going to work today instead of dealing with doggy stuff. So that's what I think where I think I'll be tomorrow. So we'll see. I might be at a point where it's actually starting to kind of have this energy system in place, and then it's going to be a matter of figuring out what to do with the rest of the stuff. So I'm going to end the stream there. Does anybody have any more questions? Oh, cool. Glad you appreciate it. And thanks for joining. And I'll just, I hope that this format's working. I am going to go into technical stuff because I like to do that and I like to like share kind of what I've learned. But also, I am trying to keep it as like here's what I'm thinking, okay? What I'm thinking is what I don't see a lot of, I see like a lot of technical streams, right? So there's a lot of those. What I don't see a lot of is like, hey, here's how you would actually prototype a game, right? If you had an actual game that you wanted to work on, like a real product, not something that's like, just like a experimental project, but like no, like an actual game that you're trying to ship, and you don't have an artist. You're just one person, and you like, here's how you would do it. That's kind of what I want this to be. and it's just to show people how to like move fast and prototype things. Um, that's what I want this to be. So hopefully that is something people want. Um, I think it's something I might have wanted, but I don't know. We'll kind of keep trying it out, and I thank you for joining me. I'll see you next time.